Hi everybody, and welcome to Theorem 2.14. We are looking at page 52 of the workbook, and this theorem is basically just going to be a formal statement of what we did in the previous example. We sort of reason through what the matrix for a linear transformation is telling us, how it relates to coordinates, and this theorem formally states that result. Okay, so let's read the statement of the theorem together here. So we'll let V and W be finite dimensional vector spaces with ordered bases beta and gamma, respectively. So beta is the basis for V, gamma is the basis for W. And we'll let T from V to W be a linear transformation. Okay, then for each U in V, the domain, we have the coordinate vector of T of U relative to gamma, and then we'd like to fill in this blank. Okay, well, the nice thing here is we kind of reason out what needs to go in the blank just by thinking about what we did in the previous example. Okay, so I'm going to start here by giving a name to the matrix. Okay, the matrix of T that takes us from beta coordinates to gamma coordinates. Okay, we can draw kind of a nice picture that helps us to make sense out of this situation. Okay, so if we start with an input U, then the linear transformation T is going to map us over to the output T of U. Okay, and we have bases for the domain and the codomain, so associated with this vector U is its coordinate vector relative to beta, and associated with this output vector T of U is its coordinate vector relative to gamma. All right, and if you think back to what we did in the previous example, what we noticed was that this matrix is a way of taking us from the coordinates of the input to the coordinates of the output. And so what we can say is that if we left multiply here by the matrix A, we left multiply U beta by A, we're going to get this coordinate vector over here. Okay, so the diagram suggests a way of arriving at this coordinate vector. It just says that we need to start here and then multiply by A on the left. Okay, so that tells us what goes in the blank here. We're going to start with U beta, and then we're going to left multiply by A, okay, which is that matrix. Okay, and there's Theorem 2.14. In the next video, we'll do an example where we look at it.